Alright, so this is the first video in our lectures on databases. I know it's not conventional to start with relational algebra, but that's exactly what we're going to do today. So first of all, we need to know some notations, and I was going to make this into one video, but I thought, well, one video is better, so we're going to talk about relational algebra. Okay, so first of all, we need to know our first operator, which is the sigma operator or the select operator. So first of all, before we do that, all we're going to do is work with queries. So the first thing, just the very simple query, is just the relation name. The relation is, if you've been exposed or you've used databases before, it's basically the table name. Okay, so if you had an experience with MySQL before, so if you have a table called student, that table is called the relation, but it's a little bit more complicated than that. We will get there in a second. So if you wrote student in a relational algebra interpreter, then that's just going to show the entries in that table or in that relation. Okay, so let's just get to the select operator. So the select operator just works this way. Okay, it takes as a subscript the condition, so condition and then relation. So for example, we're going to work, as I said, with the student relation. So we want all the students with GPAs higher than or greater than 3.7. So okay, sigma GPA greater than 3.7, and then here we're going to go, okay, student. Let's just suppose the relation is called student. So this is what this is supposed to do, is just gives all the students that have a GPA higher than 3.7. So I just stopped coding so I can add these tables or relations. So we have three relations. This one is student, and this one, and the other one is college, and the last one is just application. So okay, there are things that are similar and common between all of these, especially in the application relation. But here's the thing. So let's suppose that we wanna execute this, and when we do that, all we're going to get is just these two, and well, let's suppose that it returned it like that. So student ID 412, 3.9, and it's Mark and Emily. Okay. So now we know what select actually means, and it's mostly equivalent to select. If we're checking out a SQL from student. Okay. Anyway, not exactly, and we'll know why right now. Of course, where I totally forgot that. Okay. So let's just jump into something else, and we are going to talk about project. Okay, so the project operator, which is just pi, that also takes arguments. The arguments are the fields, or whatever you call it. It just gets student ID, just gets GPA, or gets both. If you just want the name of the student and his GPA or her GPA or their GPA, whatever, then you go and you do this. You go, okay, pi or project GPA, and hold on, this is a problem. Anyway, because I actually, yeah, let's just copy that, and name, and here just add the relation name, which is student, and this is gonna get us all the students, but without. So if you do this, it's just supposed to, hold on a second, it's supposed to return this, and this is exactly what we're gonna get. So this is a new relation out of our relation that we already had. Okay, and well, by the way, this is a mistake. It's not supposed to be the AND operator. This actually is n here. GB 3.7, and if we want something else. Anyway, so can we combine both operators to get something more powerful? Well, yes, we can, and we are going to try that right now. Okay, so let's just say, okay, we want the GPAs of this. Hold on, no. We want the name of the students, so we set project name of what. So we're going to write a query inside of another query. So okay, so sigma okay, so I'm sorry, yeah, that's right. So okay, and GPA 3.7 student. So here's exactly what we did when we did that. We said, okay, bring me all the students whose GPA is greater than 3.7, but only show me their names. So, well, this is just some basic stuff. We're just getting into the whole thing. I mean, we don't really have to talk about this a lot. I think this covered the select operator and the project operator, and we knew that we can actually combine both of them. And then we were going to talk about the cross product or a Cartesian product. So okay, first of all, we know from discrete mathematics that a Cartesian product is just we have a set that has A and B and another set that has 1 and 2. So the resulting set will be just A1, A2, B1, and B2. Okay. So for each one in the first set, well, combine it with each member of the second set. Okay. So let's suppose, and cross product is just an introduction to join, which again, if you've had any experience with MySQL or any other database framework, well, you're going to like this. Okay, so let's suppose that we want the cross product or the Cartesian product of student and application. Okay, so we're just going to say the idea. We're going to okay, so let's just copy this. This is gonna sound a little bit weird, but okay, it's just going to take each and every student, and okay, so this is gonna take a bit of time, but and then it doesn't matter, but okay. So and here's exactly what happened. So we're going to repeat this. We have 4, so we're just going to do this for Andrew because, well, we don't really have that much time. And okay, right, and finally, so the same thing is going to happen with Mark, Emily, and Sarah. And by the way, this is absolutely ridiculous because, well, I mean, for the first 3, this makes sense, okay? Andrew applied for college number 5, which is, I think, MIT, yeah, and his application got accepted, and Andrew applied for Stanford and UCLA and so on. But here's the thing. This actually is not Andrew, this is Sarah, and she got rejected from MIT, yeah. So here's the problem. This doesn't make sense because it's just a Cartesian product, okay? But we're going to talk about something else. But before we do that, we really want to do something, but we want to introduce something called a natural join, and later we're going to talk about theta join. If you had experience with any database systems or frameworks, the join is usually a theta join, not natural join, but well, we're jumping ahead. So natural join, what is natural join? So okay, first of all, a natural join, which is expressed by the little bow tie operator, is just a very specific Cartesian product, and it makes more sense because, well, let's just say that our Cartesian product didn't really make much sense, but now when we do this, but instead of the products of both, we wanted the natural join. So here's exactly what's going to happen. Same relation. We're going to get a relation that's a bit similar to the last one, but it's just going to be a little bit smaller. Okay, so no. Okay. Because now, first of all, we're not going to need Mark or Emily because they don't have any applications. But here's exactly what's going to happen. So we have 3 for Andrew and 1 for Sarah, and okay, and that's it. This makes perfect sense. This is the relation we're going to get from executing this query. We're going to get perfectly a fine relation that makes sense. Okay, so this is the natural join, and then we're going to get something else which makes even more sense, which is the theta join. So okay, I'm sorry, theta. Okay, the theta is just a condition. Okay, so we're going to say, well, so I want, so okay, so now we're going to theta join student to hold on a second for that, to okay, to application where GPA is greater than 3.7. Okay, so here's the thing, because we didn't say this a few minutes back, that Okay, join is just a Cartesian product that just eliminates the things that don't make sense. It only gets us. Okay, we have an attribute, which is student ID, which is what's common between the two relations, students and application. So it only gets us the things that have common attributes. Okay, in this case, of course, student ID. So okay, finally, all we're going to do before we show the relation that's going to result from this. By the way, let's just say greater than 3.6. Anyhow, so this is exactly equal to select, which is theta. Okay, I'm sorry, no, not theta. Which is equivalent to select with subscript GPA greater than 3.6 of the cross product, or the Cartesian product of student times application, which, well, running both queries is just going to get us the same result, which is this one. Anyway, so this is just a brief introduction. We're going to talk more about this. We're going to try an interpreter in the next video, and we're going to try to execute some of these operators in MySQL. Some of which actually not from these, but well, when we get to intersect, some versions of MySQL just don't support intersect. Anyway, not the point. Good luck and see you in the next video.